The ornithopter horns electromagnetic suspension and diamagnetic repulsive force. Common permanent magnets that are parallel, locally fixed onto a surface, parallel within vector. Around its gorge of the permanent magnet, rectangle permanent magnet solid block, exhibiting a coil alongside to its gorge surfaces in a spiral like pancake coil, inductive coil, AWG 24, audio wire gauge 24, to a surface of copper, two of those as a pair, and covering the top part of the coil exhibiting a central magnet, I have an aluminum sheet, also an iron sheet. That is the set pair of the repulsive ornithopter blades. Thermoplastic flexi deformable plastic sheet, a paddle exhibiting a central magnet metric range of a human head shape. Metal central coupled to the aluminum sheet block metal is phase voltage booster, power capacitor. The high voltage booster arcs and sends plasma ions to cross between one surface that is connected to the other is joined to a flat paddle that may deformate. Structure deformate as the change in structure as the bend or having flexibility. The module couple is of the copper sheet bearing the copper coil AWG audio wire gauge 24 and exhibiting a central permanent magnet facing upward to its repulsive side. The paddle end is fixed to the surface of the lower part of the curved metric range of the face shield to a pitch around the permanent magnet allows the two generating a charge and attraction. Thus, the central is repulsive, causing taser. Tasing one side, generating electrical energy. Ions within the central, the permanent magnet, 5 pounds, 786 ounces is the stop generating a charge. So that the repulsive force would then return away the blades from one another, pushing the frontal surface of the faceplate forward. The freedom as of the faceplate to move forward. Magnet common side to another permanent magnet common side. So, while the permanent magnet is introduced to the vector field of the permanent magnet, it moves the helmet forward. It's moving back because of the repulsive force. So the induction coil that is underneath here is sitting back current in return forcing the kinetic energy to be greater than. But because this is a low cheap battery, 9 volt, is doing that, and it's operating 2 of them, and it's almost dead. So I'm really barely getting a tase out of it. Okay, the actuator, as far as the blade actuator, this is for the ornithopter faceplate and to the permanent magnet localized with the magnetic coil, and I got to put another coil localized on the other side right here by this one, and see this one bearing a permanent magnet with a coil, and that will allow this to flap. Now the other flap panels is right there. Flat panel, this is the other part of the wing, the blade. This is the flapper that flaps